Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Mr. Cheka welcoming you, as promised, in the new video for grade 11 advanced. This video is going to be very helpful for all my students who are going to be giving the term 2 exam today. So in this video, I am selecting from the EOT exam coverage for grade 11 advanced the learning objective 17, where we solve trigonometric identities for the paper-based exam. This is a very important video. I would urge you to watch the video till the end. Towards the end of this video, last 2 minutes, I will be showing you the answer key for all the questions for this learning objective 17. So let's start this video, and I wish you all the best for your coming exam. Okay, so let's solve learning objective 17, where we solve the trigonometric identities. For this, I will be using concepts from the last lesson of trigonometry. Let's do question 45. So here we need to solve for the value of theta. We need to find the angle. Okay, theta is what we need. So for that, I'm going to move these two terms here so that I can write in standard form. So it will become 2 sine square theta minus 3 sine theta minus 2 equal to 0. So remember, the sign changes. It becomes from positive to negative when we change the sign. Now this is like a quadratic equation in sine theta. So let us replace sine theta with x in order to solve this. Then what does this become? Let's see. 2x square minus 3x minus 2. Now this is a quadratic equation which will have two solutions in variable x. So when we solve it, let's see, I will compare with standard form ax square plus bx plus c. So if you see, your a is 2, your b is minus 2, your c is minus this is minus 3 and this is 2. So how do you get? This is the value of a, b and c. Okay, you have all these values. So now you can factor this quadratic equation. There are multiple methods. Either you can use middle term splitting, or you can use quadratic formula, or you can use discriminant, or just to save time you can also use your calculator. So when you do that, you will get the two factors and the two roots. The power is 2, so there will be two values of x. The first value will be x equal to 2. The second value will be x equal to minus half if you do it correctly. Now let's go back to what was x. X was sine theta and we need theta. So sine theta equal to 2 or sine theta equal to minus half. These are the two options. But I hope you know that sine theta has a maximum value of 1. So this case is not possible where sine theta is equal to 2. This is not at all possible. So we ignore this part. There is no solution coming from here. Let's do this. Now we need theta, so you can use your calculator and use inverse trigonometry. So put the function sine inverse of minus half, and I want you to just remind you that when sine is negative, it means as per the sign convention that we are in the third or the fourth quadrant. Okay, so after school to college, that's the sign convention. So when you do this in your calculator, you will get minus 30. Now this is my reference angle. So if I want to write my final answer, we have to go to the third and fourth quadrant. As you see third and fourth. So to get more solutions, what I'm going to do, I'm going to first draw this minus 30. Let's see. So it will be, because it's the angle is negative, so we know the direction is clockwise. So from the horizontal, this is 0 degree, I will go in this direction, clockwise 30 degrees. So this will be minus 30. Now I need to find more solutions, especially in the third and fourth quadrant. So to write all my possible solution, I will write like this. So angle in third quadrant and angle in fourth quadrant. There are two possibilities. So for third quadrant, I will just again make the reference angle in the same picture. So this one is third quadrant, this one is fourth quadrant. So if you see, if I just try to make this angle, measuring this angle is 30 again, then how much is the total angle? This is 180. So 180 plus 30. So in the third quadrant, the angle will be 210. That's one solution. Now let's come to fourth quadrant. Now if I want to write like a positive angle, then the whole complete angle is 360 And from 360, I subtract this 30 degree to get the positive angle. So it will be 330 degrees. So these are the two values of theta. Now these are specific value. Now you'll read the question, you will see what it asks. If it asks for specific angle values, then you have answer minus 30, 210, 330. Okay. But if it asks for general solution, or it says find all the possible solution, then you have to give general solution. So your final answer will look like this: 210 plus k times 360 degree, because we know the period of sine theta is 360 degrees. And similarly the next solution will be 330 plus k times 360 degree. What is this k? K is any integer. It may be positive, it may be negative, it may be 0 also. So this is general solution. This is a set of all solutions. If the question comes like this. And why did we ignore minus 30, if you are thinking? Because for this question the quadrant will be mentioned as a positive angle. It will be like theta lying between 0 to 360. So we had to take all possible solutions which are positive. So I remove this negative and write it in the form of two positive angles, 210 and 330. I hope this question is clear. Similarly, I would want you to try question 46 yourself. Let's go to more questions. Okay, so now let me solve question 47 for you, and in a similar way you will be solving 48 yourself. Now if you look this equation carefully, before we solve it we have to use some trigonometric identities. What is the reason? Because this function is in sine and these two are in cos. They're all different. So let's make it like in one function only. So in that case I'm going to replace this sine square and I'm going to put in its place cos. So sine square theta is equal to 1 minus cos square theta. I'm going to use this Pythagorean identity and put it here. Let's see what we get. So 1 minus cos square theta plus cos 2 theta equal to cos theta. Now to make it into a quadratic equation, I'll also have to replace this cos 2 theta. So there are two identities I'm using. Number one is this Pythagorean, which I use here. And the second is definitely the double angle. How do you know? Because it's 2 theta. I'm going to use the double angle identity for cos, which is cos 2 theta equal to 2 cos square theta minus 1. So please remember, I've already written here very clearly 1 and 2. You have to mention, if it is an FRQ, all the steps and all the identities that you use. Now I'm replacing with this value. Now it looks like a good trigonometric equation because everything that you see here is in terms of cos theta. So I cancel whatever I can. 2 cos square theta minus cos theta is going to give you just 1 cos square theta, and I'm going to move this on the other side so it becomes negative. Okay, now what's common here in both of them? Yes, it's cos theta, so I'm going to take it outside. Inside, I'm left with cos theta minus 1. So now I can apply 0 product property. What does that say? I've taught you many times, but quickly I will repeat. If the multiplication of two things is equal to 0, that's your 0 product property, then each of them is 0. So can I say the first one, cos theta, is also 0, and the second term, cos theta minus 1, is also 0. So let's get our theta from here. Use calculator. Take cos inverse at each step. And from your calculator, you will be getting the following angles. So this will come out to be 90. And see, now again, the quadrant which is mentioned is theta lying between 0 to 360. Means all the four quadrants. So I can take more values. The next value will be at 270. Similarly for cos inverse 1, it will be 0 and 360. So let's see how many total values we get. That's the first value, second, third, fourth, total 4 values. Now these are specific solutions, but if the question asks you for general, again you will do the same thing. So we can write general solution. So how do we write general solution? General format is to just add the period to it. So I can write 0 degree plus k times 360 degree. I write that for this one, and for this part I'm writing theta as, let's take only the first one, 90 plus k times 180. This is the final answer. I'll put it in the blue box so that you know that if the question asks you for general final solution, this is what you have to finally give. Now, some of you might be thinking why I did not write the answer with these two, and the reason is that these two answers are contained in these two, which I put as the final answer. How? Let's check. For example, if I take the first solution, this one, theta equal to 0 degrees plus k times 360. So if I take my k to be 1, then I get this also. Similarly, for this one, if I take k to be 190 plus 180 is 270. So these two answers are repeating. So only the final answer for the general solution can be got from this part. Okay, so I hope this is clear. Please do 48 similarly. I will provide in the end of the video all the answer key for the final answer. So please stay glued. Okay, now this is a very important trigonometric word problem. If you see a trigonometric equation is given with some conditions and you need to find these two things. So let's read it together. During an ocean tide, the depth y in meters, so y variable represents the depth and the unit for measuring the depth is meters, of River Thames in London, which varies as a sine function of x. So this is the function which is given for the depth. X is these values. On a certain day the function was this, midnight, so on, and you have to find the two things. Part A first, we will do that, and next moving on we will do part B. So in part A, what is the maximum depth of the river Thames? That means we need to find y. What is the maximum value of y? And I hope you know that to find the maximum depth or the maximum value of y, we need to plug in the maximum value of the sine function. It's a sine function. So remember and revise and recall what is the maximum value of sine. So the maximum value of sine can be obtained by replacing the sine function with 1, because 1 is the maximum value. So I will put in place of sine this whole thing which is given in the question, pi by 2 x minus 4. This maximum value is 1. If I'm just maximizing this function, then it is always 1. So I replace this whole thing with 1 to get my maximum depth. So 3 times 1 plus 8. So my maximum depth is 11 meters. That completes your part A. Let's go to part B. For part B, at what times does the maximum depth occur? That means it is asking about the value of the time. So let's do it. So for part B, you know that you will get the maximum depth when, as we used this part, I'm going to just use this and copy for part B. So I will put sine of pi by 6 x minus 4, this whole thing as 1. This is when the maximum depth is going to happen. So now you need to find the value of the angle. So the value of the time. So time is corresponding to variable x. For part B we need x. For part A we wanted y. That's the difference. So sine of this is 0. Let's use calculator, use inverse. So put inverse of 1. That will come out to be pi by 2. So now simplify, cancel. Some terms are going to cancel, pi will cancel. So this goes here. X minus 4 is 3 by 2. Sorry, 6 by 2, which is 3. So x is going to be 4 plus 3, which is 7. So what is the maximum? What are the times at which the maximum depth occur? If you see, there are two units given. It's like after midnight, there is 11 a.m. and then accordingly we will be having for PM time also. So can I say, if I take both the answers, that maximum depth occurs at 7 a.m. and 7 p.m. That's how you solve it. So that completes this important word problem. Okay, now let's similarly solve question 50. This is a very important question, and so is 51. Let me do 50 for you, and then 51 similarly you can solve yourself. Now if you look at question 50, it has different trigonometric ratios. There's cos, there is sine 2 theta, there is sine theta. So definitely here we are going to use double angle. Very clear. So the first identity I will use is the double angle for sine, which says sine 2 theta is 2 sine theta multiplied by cos theta. Okay, what else we can use? Let's see. Now this is cos, this is sine, both are different. So let's see what combinations we can do after I apply the first one. So cos theta as it is, inside I multiply and I put the values of them. Okay, so this is what you get. Now open the brackets, multiply. So this is going to be 2 sine theta cos square theta minus 2 sine theta plus 2 equal to 0. Now I need to change in one trigonometric ratio. This is sine, this is sine. So let me uh, change. Let's see what I can take common. So first I take common. If you see 2 sine theta, 2 sine theta, both are common. So I will take it outside, and inside I am left with cos square minus 1 plus 2. Now easy to identify that here Pythagorean is going to reduce your question. So this whole value is equal to minus sine square theta plus 2. So now open the bracket, multiply, and this is going to be minus 2 sine square theta plus 2 equal to 0. Oh sorry, this was 2, this is 1. So the power gets added, so this becomes 3. This is important. Now you must be wondering how I get this. So let me explain. In the bracket, you know 1 minus cos square theta is sine square theta. This is the Pythagorean that I'm using. Now in the question you want to replace cos square minus 1. So I will move this term here and this here. So when the sign moves, it becomes minus sine square, and when this whole moves, it becomes what you want. So therefore I replace cos square theta minus 1 with minus sine square. Again, for the powers, this is 1, this is 2. So when you multiply, the power gets added. So now let's little bit change this equation. Move the 2 on the other side. So minus 2 sine cube theta is minus. Now minus and minus becomes plus. I can also divide by 2 just to make it easy. So sine cube theta equal to 1 is the final thing that we get. Our final goal for this question is to give the value of theta. So at this point, if sine cube is 1, I can take 1 by 3, 1 by 3. I'm taking like a cube root. Okay, so sine theta is also 1. So theta is sine inverse of 1. Now at this point you can use your calculator. Plug in sine inverse 1. So this is going to give you 90 degrees. Or if the question is having the units of radian like this one, then we can write as pi by 2 also. So for just this question, I want to specify, if you read the question properly, the unit for angle is mentioned as radian. So pi by 2 radians we will use. Now this is particular solution. It's like a specific solution. But if again the question asks you for general solution or all solution, then you will give theta as pi by 2 plus, yeah, add the period. So now I will not add 360 degrees because it is radian. So I will add 2 pi k, where k is integer. Okay, so I added the period here, this time in radians, 2 pi radians. So that's your final answer. Similarly, try 51 and check your answers in the end of this video. Moving on, the next important question in today's session is question 52. I would urge you to solve it with me carefully and not to do any silly sign mistake. So step 1, I will use sine 2 theta. So you know already from the previous question that this double angle is equal to this formula. Let me replace. So 2 sine theta cos theta minus, now this cos theta I'm moving here. Just I'm trying to combine the terms and let's see what happens. And when I move this term on the other side, it becomes negative, that's for sure. I'll keep it together. What else do we have? We also have square root 3 by 2 minus 3 sine theta. So what did I do actually? I moved both of these terms on the left side, change the sign so that the right side becomes 0. Okay, now let's see what I can take common. Very easy to identify that cos theta is common, so I take cos theta outside. 2 sine theta minus 1, that's what I get here. Now for these two terms also I would like to take something common. So how can I do that? Let's see. So to do that, I will take I will take square root 3 by 2 common. So what's left? 1 minus 2 sine theta. Now you must be wondering why I'm doing this kind of a thing, and it will be very clear to you if you see these two terms. Can you see these two terms are same and they just differ by a negative sign? So when I'm trying to solve this question for the angle, for the theta, I will try to change the sign here, make it negative, and flip this term so it will become the exact same 2 sine theta minus 1. See this one. And now my whole purpose of doing this modification or this change was that in the next step, I can take this common term outside and factor the equation and get to my answer. So this I take common. Now what's left inside? Cos theta minus 3 by 2. So do you see that now we have a zero product property, same like previous. Multiplication of these two is 0. So if I apply, each one of them is going to be 0. This is also 0 and the second term is also 0. So let's get our theta from here. So sine theta is 1 by 2. Cos theta is square root 3 by 2. Use your calculator, use inverse trigonometry, plug in sine inverse and you will get two answers from here, 30 degrees and 150 degrees. Forgot to mention that for this question, again, we are using degrees from 0 to 360. So all four quadrants are included. That's why after 30, I also get the next solution, 150. For this one, cos inverse of square root 3 by 2 on your calculator will lead you to two answers. One is 30 degree and one is 330 degrees. So we have taken in all quadrants. So this is first quadrant, this one is second quadrant, and this one is the fourth quadrant. So if I now combine all the answers, then how much we have? One is same, 30, both of them. So I will not write two times, just one. Then is 150, then is 330. So three answers or three values of angle in this quadrant I'm getting. These are the particular solution. Now let's write general solution. So I know that by now you know that for general solution we just add the period is 360. So the first general solution is 30 plus k times 360. The second general solution is 150 plus k times 360, and the third and the last is 330 plus k times 360. So before I move to the next question, just want to remind you one thing. Even though you see like these are three solutions, but these are not three, these are infinite, so many solutions, because every time I change my value of k, I get a different solution. So if I make k 0, I get 30, 150, 330, three solutions. If I make k1, I get the next three set of solutions. So like so many I can find as long as they are in this range or domain of theta. Okay, so this is how you solve the long question 52. Very important. Please solve 53 also yourself and check towards the end of the video your answers. Okay, so on this slide we have 54, 55, out of which I feel 55 is a little more tricky, so that's the one I'll do for you. 54 you can try yourself and in the end check the answers. So here if you see two different trigonometric ratio, we have cos, tan, and then cos square. So step 1, I will try to convert into 1. So tan theta, quotient identity, I'm going to apply sine over cos and plug it in here. So let's see what we get. Things are going to cancel as well and the equation will simplify. Okay, also I will move at the same time this minus 1 on the other side. The reason being I need equal to 0, I need an equation on one side. So this cancels, so I'm left with sine theta minus 2. Now here it is sine, I'm getting, here I'm getting cos. So let me change into sine. So what is cos square? Again, I'm now using Pythagorean, 1 minus sine square. So I replace and I convert everything into sine. So let's do that. Open the brackets, multiply. So this is sine theta minus 2 plus 2 sine square theta plus 1 equal to 0. Okay, now let's combine what we can. So this becomes 2 sine square theta plus sine theta, and I can combine the minus 1 with the plus 1. This is what I get. Now this looks like a perfect quadratic equation in sine, so I will replace just like I did in the beginning of the video when I solved the first question on this. I would urge you to use your calculator to save time, and then you will get two answers. Sine theta is 1 by 2 and sine theta is minus 1. Use calculator, do sine inverse, and get your answers here. So let's see what we get. From the first part, I'm getting two values, 30 and 150. From the second one, I get 270, but this time I will reject this 270. Why? Because if I put in this equation, the one which was in the question, back again, theta as 270, then tan of 270 is undefined. It's not at all defined, so it will not be a good solution. So this is like an extraneous root or extraneous solution. So I reject. This is not possible. I don't take it. So only these two solutions I will take, which are particular, and in order to write, I will write here the final answer, which is the general solution for question 55. I'll add the period, that's the last step. So I add k times 360, and the next solution is 150 plus k times 360, where k is any integer. Okay, so this is how you write the final answer, which is your general solution for question 55. Now it's time to check your answers. So as promised, I will now be sharing the answer key for all the questions for FRQ Learning Objective 17. So please check your answers and let me know in the comment section if you've got them correct or not. This is the answer key for question 48. All the steps are given to you, so you can check your answers now. Also, for the last few questions of Learning Objective 17 from question 50 to 55, these are the final answers. You can check in the question what is given. If the unit is given to be degrees, you'll give your answer in degrees. If it is given in radians, you will give it radians. Okay, so that brings us to the end of today's session. I hope you found it useful. Please like, share, and subscribe to the channel. Let me know in the comment section if you have any questions or query, and I'll see you in my next video, which will be coming up for Learning Objective 18 from the FRQ paper-based exam, where you'll learn how to find determinants and inverses of 2x2 and 3x3 matrices. So that brings us to the end of today's session. I wish you all the very best for your coming exam. If you have any questions or queries, do let me know in the comment section. Also, you can give your inputs, which is the video that you want me to cover next. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, girls.